he wants to obey the rule of inertia. Okay, let's now talk about the second law of motion. So far we were talking about the first law of motion, the second law of motion. Now, if the first law of motion enabled us to define force, we are going to use the second law to measure force. We haven't really come across a way to measure force. This is where we're going to do measuring force. Now, tell me, what is the function of a net force? What does a net force do on an object? A net force produces acceleration on an object. Whether the object is at rest or in a state of motion, the function of a net force is to produce acceleration. So when an object begins to move, it has acceleration since its velocity changes. In the same way, when an object changes its state of motion, it has acceleration because its velocity changes. Whenever there is a change in velocity, there is acceleration. Now, whenever an unbalanced force acts on an object, in other words, when a resting object begins to move, it happens only when an unbalanced force acts on it. A moving object changes its state of motion only if an unbalanced force acts on it. So what does an unbalanced force do? An unbalanced force produces an acceleration. Whenever an unbalanced force is acting on an object, that object will accelerate. And that therefore leads us to the second law. What does it say? The second law is a direct relationship between the unbalanced force and the acceleration that produces on an object. And this is the statement. The unbalanced force acting on a particle is proportional to the acceleration it produces on the particle. That means you apply a greater unbalanced force, it will produce a greater acceleration on a given particle. So if you have a given particle of mass m kilogram, if you keep on increasing the unbalanced force, the acceleration also will keep on increasing. If you decrease the unbalanced force, the acceleration will decrease proportionately. So the statement of the second law, the unbalanced force acting on a particle is directly proportional to the acceleration it produces. Can you write down that as a mathematical statement? Yes, F net force, is directly proportional to the acceleration A. And you know that whenever we make a statement like this in physics, the proportional sign can be replaced by an equal sign, and so you can say F net equal to a constant times the acceleration. And what is this constant in this case? It is the mass of that particle. So when a net force acts on a particle of mass m, an acceleration A is produced on the object such that the net force equal to mass multiplied by the acceleration. Look at the way we are now coming to quantify force, and therefore we can now measure force. This m is a constant and it is the mass of the object. Well, let's now talk about the unit for measuring a force. What is the unit in which you're going to measure force? Every physical quantity needs a unit for measurement, because you remember in the beginning, as I said, the nature of measurement is made clear by the unit of that quantity. When you say 2 meter, you know the measured quantity is length. When you say 5 meter per second squared, you know the measured quantity is acceleration. What is the unit for measuring force? Let's write down the second law equation. The equation that describes the second law of motion is the net force F net equal to ma. Now, if you now take 1 kilogram and use sufficient force to produce an acceleration of 1 meter per second squared, you can see if m equal to 1 kilogram and acceleration is 1 meter per second squared, then 1 kilogram times 1 meter per second squared will be equal to 1 unit of force. Is that right? Yes. Now, so mass is measured in kilogram, acceleration is measured in meter per second squared. Therefore, it is easy to define a unit for force. What will be the unit for force? It will be kilogram multiplied by meter per second squared. This is the unit for measuring force. Kilogram meter per second squared. Now, this has a name, and that is called a Newton. 1 kilogram meter per second squared is called a Newton. And now, if I ask you, you have a fair idea how much is 1 kilogram, is that right? I have showed you here, I'm holding a mass of 1 kilogram. This is 1 kilogram mass. Now, the amount of force I need to apply on this to produce an acceleration of 1 meter per second squared, that much force is called 1 Newton. So the unit for measuring force is a Newton. Now, the amount of force that produces an acceleration of 1 meter per second squared on a particle of mass 1 kilogram is called 1 Newton. Well, I have a scale here that is marked in Newton. Let me see if I could show that to you. Now, here is a scale that is used for measuring force in Newton. Well, let me see if the camera will focus onto it. You can see, you can measure up to 10 Newton there, and I can apply a force on this. When I apply a force, you can see the force I'm applying is 2 Newton, 3 Newton, 4 Newton, 5, and so on. I can measure force in Newton using this. Now, I'm going to hang a kilogram. Look at this. This is a kilogram from the scale. Now, tell me, what is the force that is stretching the spring now? It's about 10 Newton. That means this 1 kilogram is pulling the spring now with a force of 10 Newton. Alright, I'm now going to put a 100 gram in there, and can you tell me what is the force that is read there? Well, the force is 1 Newton. So can you get a feeling of how much is 1 Newton? Here I have a mass of 100 gram hanging from the spring, and the force this applies when it is hanging is 1 Newton. We will look at this as we go on. Let's now look at the difference between mass of an object and its weight. Now, very often this is confused by even scientists, because if I ask a scientist, hey scientist, what is your weight? I know in America, invariably, he will tell me 150 pounds. Well, pounds in English units, that is the old unit, apparently it is still used in America, is used for measuring mass and not for measuring weight. In SI system, the unit for measuring mass is a kilogram. Now, what is the difference between mass and weight? Let's discover that. Now, it is the mass of an object that determines its inertia. You see, a massive object, it is very difficult to move it, whereas a light object, you can easily move it. Therefore, mass of an object can be simply defined as its inertia, the amount of inertia. Is that right? Now, you have a great big box. It takes a great amount of effort to move it. You see that? It has a great inertia. Whereas a golf ball, well, even a child can move a golf ball. The inertia of the golf ball is very small. The amount of matter in the golf ball is very small. Whereas the amount of matter in this box is very great. It has a greater inertia. Therefore, we are going to define mass as a measure of the inertia of the object. That's a very convenient way to define mass. If you now look at these two masses, I have two masses here, which has greater inertia? Well, the one on my left hand, when you watch it, it will look like my right hand. Well, this has a greater mass because it has a greater inertia. This has a lesser mass, it has less inertia. So, mass is a measure of the inertia of an object or a particle. Whereas, weight is something that makes an object fall. Well, if this object has no weight, it cannot fall. When I drop it, it falls because it has weight. So weight is an object that makes object fall. What does that mean? What does the process of falling means? Now, if I have a basketball here, it is at rest here. Falling means it is changing its state of rest. So what is making the ball fall? When I take my hand off, there is a net force that is pulling the ball towards the earth. It is called the force of gravity. Is that right? So it is the force of gravity acting on this object that is going to make it move. In other words, weight is a force. It is the weight that makes the object fall. And what is weight? It is the pull on the object by the earth. It's a force of gravity. Now, weight is a measure of the force an object experiences due to the gravitational pull of the earth on it. So, whereas mass is a measure of inertia of an object, weight is a force. You see, very different things. That means if a force is acting on an object, that force must produce an acceleration. The net force on a freely falling object is called its weight. And now remember, whenever there is a net force, when the object falls under the action of that net force will produce an acceleration. That means the moment I let it go, it is going to accelerate. That means the weight of an object will make it accelerate. And the acceleration produced by the weight of an object, or the acceleration produced by the force of gravity on an object, is called the acceleration of free